Welcome to Let's Roger That. I'm Gilles, and today we're going to diagnose an issue with my lathe. Lately, my South Bend 13, a 1944 model, has been flipping the breaker and had a hard time starting. So I thought, is it the capacitor? Is it a bearing? What is it? So, first thing I did, rather than dismantle the whole motor assembly, is check all the connections, the electrical connections, and nothing is loose, which would cause an increase in current draw and flip the breaker. That is not what's causing it. Then I thought, oh boy, maybe it is a capacitor. But before I go there, I thought, well, I better check to see if the bearings could be an issue. A couple of years ago, I made a video replacing the bearings to this large pulley, right? The lower assembly where the cone pulley is located. But it wasn't the motor at that time. This time I'm thinking, well, that's probably what it is. But nevertheless, I did check the cone pulley bearings just to be sure. When inspecting your lathe for this kind of thing, being methodical is pretty important, otherwise you'll just go all over the place. So if you start, you got a flame, you have a breaker flipping in your electrical box, then there's too much current being drawn. So the logical place to start first is to see if you've got any loose electrical connections. So you go through the whole thing, as I said. Then you check for, you check for bearings. So I know I changed these cone pulley bearings, but nevertheless, I did this. Normal thing, right? No noise. Now when the belts were on, I could hear a noise. So what's the problem? Then I thought, okay, the only other pulley involved is the ones for the motor. Let's check this out. Ooh, loose, noisy. And I can feel the movement. Now, it could be just a one bearing, but when you do a job like that, you got to do it all. So the first thing we're going to do here is take that motor off of the assembly. Now that I've got the motor off of the lathe, check this out. Clearly, the rear bearing has issues, or there's issues inside, whatever they are. Well, let's take this thing apart. Here, I thought, well, I might as well take the cover off that starting capacitor and just have a visual look at it. I don't see any bulging. I'm an electronics technologist, and really a clear sign of this thing going wrong is simply if it's all bulging out. This one is not. Now, it's not able to start the motor, clearly, or it's resisting, but that's because of those bearings that are probably all shot up. So I'm going to keep this one for now and see how it works out after I change the bearings. The whole motor assembly is held by 4 long bolts, and the nuts were here, so those are removed. I've got these long bolts here. They come out nice and easily. So now I'm going to proceed to the next step, which is to uncap this thing and see what's underneath. Oh, before I forget, I did find that this fan is a snug, therefore it's causing noise. So I've taken the assembly out of the motor casing. I don't see any damage. It seems a little bit rusty and whatnot, so I'll clean that up a bit. But as far as the bearings go, those are NSK 6203s. So I've just placed an order for some, should have them in a couple of days. And even though I said I wouldn't replace the capacitor for about $20, there's no point not doing it. So I've got that on order as well, and now it's a matter of waiting. The motor's all in place and whatnot, and everything is replaced. And then here's what happened. Plug the machine back in the 15 amp circuit, and the breaker flipped again. So then I resorted to plugging the lathe into a 20 amp circuit, and it runs better than it ever has. So, lesson learned here. That's why reading the inscriptions on the motor plate is important. Lesson learned. But my lathe back in action, and I'm a happy man. So, thanks for following along. I hope this is going to help someone along the way. And please subscribe, like the video, and take care. Bye-bye.